Welcome to topic 2 of network security concepts. And this topic is about secure network administration. Secure network administration and ports, protocols, and wireless technologies, and devices, and associated technologies. So, first of all, looking at secure network administration. So, the topics that are required by the SQA to know about for this, we'll just go through these one at a time and give a little bit of detail on each one. So the first one is about firewall rules. So a stateful firewall is a firewall that monitors the full state of active network connections. Okay, so this means that stateful firewalls are constantly analyzing the context of traffic and data packets. Now, a stateful firewall is slightly more, shall we say, intelligent than a stateless firewall. Okay, a stateless firewall, an example of a stateless firewall would be an access control list. And an access control list can only permit or deny traffic based on a set of rules. Whereas a stateful firewall, like the Windows firewall, can understand the state of a connection. Okay, now the next generation or the next level of intelligence beyond a stateful firewall is a stateful packet inspection firewall. Okay, so as in a stateful packet inspection firewall, the state of the connection is monitored, but also the contents of the packets. Okay, so if we think about these three firewalls, the most simple one, an access control list, we can create these on routers. We also have these on Windows shares. You'll see anything that has permit or deny with tick boxes or a set of linear rules would be an access control list. And this is just a set of ordered rules, and each rule specifies a set of conditions a packet must satisfy. And when a switch or router determines that an ACL or an ACE, an access control entry, applies to a packet, it tests the packet against the conditions of all rules. The first match determines whether the packet is permitted or denied. If there's no match, the switch will apply the default rule. Okay, so filtering and packet inspection. So packet filtering firewalls watch the following fields in a datagram. So they look at the source IP, the destination IP, the source port number, the destination port number, and the protocol type. And using those fields, a packet filtering firewall can either permit or drop the packet in either direction. Packet inspection involves opening up the packets and looking inside them. So for example, if you sent some traffic that was malicious traffic into a network, but you sent it on port 80, and I already had a firewall rule that said port 80 was allowed for HTTP, then that packet would be allowed through. But if you had a firewall that could look in to the packets and it could see that that information was not HTTP, it was some kind of encrypted data, then the packet inspection firewall would know to deny that. Okay, it would be intelligent enough to deny that. So that's the third level, actually looking in the packet. So the first level is just permitting or denying based on IP addresses. Then you can have port numbers. Then you can have a stateful firewall that can monitor connections as they open up and close, like the Windows firewall. And then we can have a kind of newer, more intelligent generation, which is called a stateful packet inspection firewall. So those are the three types of firewalls we need to be aware of. And now looking at VLANs. So VLANs are sometimes called this thing up here, .1Q. Okay, this refers to the IEEE code 802.1q. Okay, that's what dot. That's a dot there. Okay, that percentage full stop, or Americans call that a period symbol. So 802.1q can be written as .1q. Okay, and this is a standard that supports virtual LANs on an Ethernet network. Okay, now what we have here, okay, is on this top line here, we have a normal Ethernet frame. Okay, so this frame here, this layer 2 frame, has no VLAN information. Okay, now a frame that uses VLANs has this blue section here, okay, has this part added to it. All right, so this little section here, and that is called an 802.1q header, and in there is the VLAN identification information, including the VLAN number. Okay, so when we send a frame, we can put a VLAN number in there, and the switch will know to use that VLAN number to identify the frame. So we can use VLANs to logically segregate or segment networks at layer 2, and we can also use VLANs for enforcement of security policies. So for example, it might be sensible to have a department called finance or a department called management on their own VLAN. And although this doesn't provide any encryption, it does provide a separation logically at layer 2 for security. So port security is something that we can enable on a switch port, and we have 3 types. Static secure MAC addresses are statically configured on each switch port. Dynamic, so MAC addresses are learned. And then we have sticky secure, and this is probably the most common one that we would use. MAC addresses are learned dynamically, and then they stick. Okay, they stay once they've been learned. So those are the 3: static, dynamic, and sticky are the 3 different switch port security MAC address modes. Okay, log analysis. So another topic in secure administration would be analyzing logs. Now, according to this quote here, it's an art and science seeking to make sense out of computer-generated records. And it's the process of creating such records is called data logging. So here's an example of a log file down here. We usually have timestamps and then what happened at those timestamps. And often in administration, if we want to go back and try and trace something that's happened, we'll go through the logs. Okay, we'll go through the log files. Now, looking at some secure devices for secure administration. So we talked about some different technologies. This is some devices. So the first device we need to be aware of for this course is a firewall. It's a network security device that monitors incoming and outgoing network traffic, and it establishes a barrier between a secured and controlled internal network that can be trusted and an external network that would be untrusted. Okay, we can think of these as 2 zones, okay, the trusted zone and the untrusted zone, or the LAN and the WAN. Now, a firewall can be a hardware device or a software device. There's several different types of firewall that you can get. Remembering back to the beginning of this topic, within that we have our stateful, stateless, and stateful packet inspection firewalls. So a good way to think of a firewall is it's something that will deny packets. Okay, and compare that to a router. A router's purpose is to forward packets. So a router will forward packets at the network layer, at layer 3, by default. That's what it likes to do. And if you try and think of a firewall as something that will deny packets, so in some sense the opposite of a router. Now, a router connects two or more networks together. Okay, that's what a router does, and it creates a route between those two networks. Now, in the UK, we don't generally refer to a kind of long distance motorway as a route, So in America, they have these like interstate highways they give them route numbers. So that's if you think of a route as some kind of a path, they call them routers. Okay, so to go a route, uh, in American sense, is to go down some path or some road. So a little bit of kind of ambiguity between British and American English there, but just something to think about. So a router performs packet forwarding, and it makes the decisions of forwarding based on the contents of its routing table. And its routing table is just a small database of destination routes that the router can forward packets out of. Okay, and another thing to consider is a router only forwards packets. Okay, and when a router forwards a packet, this doesn't mean it has any knowledge of the return path. Okay, that's one of the laws of Cisco IP routing. Okay, switches. So a switch is a network device that's often at layer 2 of the OSI model, and if routers forward packets based on layer 3 addresses, then switches forward packets based on layer 2 addresses, based on physical addresses. And we can also think of a router as a software device and a switch as a hardware device. So physical addresses, hardware device. Proxies and gateways. So a proxy server acts as a gateway between you and the internet. It's an intermediary server separating end users from the websites they browse. If you're using a proxy server, internet traffic flows through the proxy server on its way to the address you requested. So one way you can set up internet monitoring is to set up a thing called a transparent proxy server, and this will just run the internet traffic through the proxy server, logging it as it goes on its way out to the internet. So we can see this proxy server acts as a intermediary server between one device and the internet. Right, a VPN. So VPN is a virtual private network, and this extends a private network across the public internet. So there are different types of VPNs, one of which is an IPsec VPN. And we can just think of a VPN as an encrypted tunnel inside an otherwise public network. VPNs come in different types, and a common VPN to use these days would just be a VPN through a browser extension, and end users might use this to change the country that they appear to be in. Maybe if they want to watch a football match, they might want to put the VPN to the country of the game. Let's say they want to watch the Italian football, they might put a VPN to the Italian IP address. Not something I've done myself for football, but I think that's a fairly straightforward example. So, protocol analyzers. The most common protocol analyzer that we will use is called Wireshark. And Wireshark is a piece of software that's used for capturing packets on a network so that we can visualize them. And it's quite common, just like looking through a log, to look through a Wireshark trace. And this is actually called a PCAP file, the Wireshark PCAP file, a protocol capture file, I think it stands for. And this will give you a layout of everything that's happened on the network. So a DMZ, or DMZ, a demilitarized zone. Now, I said just before that we had two zones in a firewall. I use the word zones, okay? We've got our trusted zone called the LAN, and we have this untrusted black cloud here called the WAN, the Wide Area Network. But it is possible to have a third zone, and that third zone is the demilitarized zone, the DMZ. And we can think of this as a semi-secured area that's between the LAN and the WAN. And it's quite common to put a public-facing web server in there. So while the rest of the organization is secured in the LAN zone, we can have our public-facing servers in the demilitarized zone. And it's a small, isolated network that's just usually illustrated in a diagram as being off to the side here. So if we were running a public-facing web server, we wouldn't want to put the web server next to your computer inside the local area network. We would want to put the web server in its own isolated area called the demilitarized zone, which has its own security policy, and users can come in from the WAN and head up to here to the web server, as opposed to coming in and browsing a web server that's inside the local area network. Some other technologies, subnetting, which you would look at in the CCNA, that's just the practice of dividing networks. NAT, network address translation, is a method of remapping a public IP address to private IP addresses. Telephony, so electronic transmission of voice, fax, data, and nowadays voice over IP communications. Virtualization, this refers to creating virtual machines. Now these could be virtual servers, virtual clients, virtual test machines. And finally, cloud computing. So especially now in the current climate that we're in, cloud computing is making a lot of progress just now. So those are all the technologies that we need to be aware of for this course. Now some ports and protocols. So ports, protocols, and wireless technologies. The first one is HTTPS and SSL. So for this course, it's okay to call it HTTPS and SSL. However, the real name is actually Transport Layer Security, TLS. Okay, SSL isn't really used anymore, but we still say things like SSL certificate. Okay, but it's not technically an SSL certificate. It's actually a TLS certificate. That just the name Transport Layer Security has never really caught on. And HTTPS is an extension of HTTP. And what we do is we create a secure layer that allows information to be encrypted. And I've tried to find a graphic here online that illustrates that if you imagine there's layer 4 there, the port numbers, and here's layer 7 here, we can have this TLS layer sitting in between here. Okay, so some other S protocols. SSH is a secure shell. It's a way of logging into devices. Hopefully everyone's had a chance to try SSH. SCP is a way of using SSH to copy a file between two machines. Okay, the SSH secure copy protocol. And finally, the SSH file transfer protocol is a way to transfer files whilst using SSH for security. So SCP, SSH, secure shell, and then secure file transfer. It doesn't actually, a lot of people call this the secure file transfer protocol. It's not actually, that's not what it's called. It's actually called the SSH file transfer protocol. But rather than having to say that hundreds of times a day, it's easier to just say SFTP. So SCP, SFTP, and SSH. And We'll give a little demo of those. IPsec. So IPsec is, I said that there were different types of VPNs. IPsec is something that's used to create a tunnel between two routers. Okay, so we can set up an IPsec VPN to encrypt private traffic and send it through a tunnel over a public network. SNMP is the Simple Network Management Protocol, and this is used for monitoring information, or it's used as a monitoring and alerting system. Now, SNMP has a concept called traps, and we can set the trap level. And you might have a device like a printer, and the printer might support SNMP, Simple Network Management Protocol, and you can say to the printer, can you please tell the SNMP server when you run out of toner or when you run out of ink? Can you alert us? And you could have an SNMP server running, and you can have these alerts popping up. Okay, so a bit about security in Wi-Fi. So in Wi-Fi, 802.11 is the family, just like 802.3 is for Ethernet. And Wi-Fi has lots of different kind of abbreviations and standards. So things we need to know for this course: an SSID is just what you can think of as a network name. Okay, so when you go into a coffee shop and they have like coffee shop Wi-Fi is the SSID. The service set identifier is the fancy name for it. Really, it can just be called the network name. If you went into a small business and you said, what's the SSID? It's unlikely they would know. But if you said, what's your Wi-Fi network called? What's the name of your Wi-Fi network? They're likely to know. What they're actually talking about there is the SSID, but they're unlikely to know that it's called an SSID unless they do a lot of networking in their spare time. So Wi-Fi can be divided up into channels. These channels are just a division of the frequency. And the 802 standard provides several distinct radio frequencies. So there are standards within standards, and the two most common frequencies we use are 2.4 and 5 gigahertz. And within those, we've got a progressing set of standards. So we started off with 802.11b, then we had 802.11g, then we had 802.11n. Don't forget about 802.11a. Now I think we're on AC or AE. And with each improvement, we just get a slightly better version, faster throughput, and things like that. So security in wireless networks. Now, I have a little bit of a mental block about remembering what these things stand for. So WPA2 is likely the most common type of security that you're going to have in your Wi-Fi network at home just now. And this superseded, excitingly, WPA1. And WPA stands for Wi-Fi Protected Access. Now, the old system, before we used WPA 1, 2, and 3, we used to use a thing called WEP, Wired Equivalent Privacy. And this had some security flaws. So that's why we use this one now, okay, WPA. Usually 2, but in the future we'll be moving to WPA 3. So some other things that we just need to be aware of for this course. MAC address filtering is something we can do usually in the settings of a Wi-Fi router. We'll have an option to permit or deny devices based on their MAC address. And TKIP, or 802.11i, is a thing called the Temporal Key Integrity Protocol. Okay, and this is just a way of adding an encryption method onto WPA, Wi-Fi Protected Access. So the things we need to know for this course are: what's MAC filtering? What does TKIP do? what's WEP and why don't we use it anymore? Because it isn't secure. And we now use WPA 2 normally. I have not seen 1 for a while. And I have seen on some newer routers WPA 3. So that is the theory content for topic 2, secure access and devices. So I'll stop for questions in a minute. What I'm going to do is just give you a demonstration of some of those copying technologies that I talked about. So let me just jump all the way back to slide 1 here, just to leave something better behind. Right, let me make this bigger. Okay, so let me just change my font size to make this a bit easier for everyone to see. So let's just go for, say, 22. Okay, so I have a Raspberry Pi that acts as my print server. So I'm going to try and show some of these 3 protocols that begin with S on the Raspberry Pi. So I just need to try and remember the IP address of the Raspberry Pi. I think my CCTV's on 10. My scanner's either on 11 or 12. Let's try 11. Okay, so there's something on 11. Anything on 12? Something on 12. Is that the scanner? Okay, let's just try and SSH to Michael at 192.168.100.12. This connection refused. Okay, notice that this is on port 22. So I've actually got the port number set to 2222. So the way we specify the port in the SSH command is using this -p flag here. So let's try that. Okay. So it's talking back. It's saying, do I want to accept this key here? So type yes. Okay, now it's asking me for the password. So let me just see if I can get my password right. Good, I'm in. So using the SSH protocol, I've connected to my print server. Okay, so you can see, look, this is my IP address here, .6, and this is the IP address of the remote server. Although it's not very remote, I can actually see it in the corner of the room, blinking away there. So let's see how long this has been up for. So uptime. Okay, so this has been up for 119 days. Oh, and there's 3 users logged in. Who could they be? Let's have a look at who's logged in. Pi, and Michael. Okay, that's good. These have been idle for 119 days, and this is just in here. So the command to show who's logged in is just W. Okay, I think it's maybe workers, man W, W. Show who is logged on and what they're doing. Okay, I don't know why it doesn't give any explanation as to why it's W. So I'm logged into the Raspberry Pi now, and if I open another terminal, okay, let's just open another tab. I'm logged into my local machine here. So if I just do IP address show on this machine, okay, we should be able to see somewhere that my IP address is 192.168.100.6. Let me just try and clean this output up a wee bit. So IP address show, and let's only show inet. Okay, that's a bit better. And then if we only show inet and we don't show inet 6, so we can, using this command grep, we can exclude things, I think, with the V. See if that works. Ah, there we go. So that gets rid of all the inet 6. There's my address there. These are just some of my virtual subnets. I think that's VMnet 1, VMnet 8, and VMnet 15. So here's my IP address here, 192.168.100.6. And over here, if I do IP address show. Okay, here's my IP address here, 192.168.100.11. So I should be able to ping 192.168.100.11, and it's replying. Now let's just say, okay, let's do ls. So ls here shows that I've got these folders: code, documents, downloads, music, pictures, R, and VMware. Okay, and over here on the Raspberry Pi, let's do ls, and I've got all sorts of stuff going on here. So let me just cd to my downloads folder, do ls. All right, I've got some test files here. Now let's say I wanted to copy this test file from this machine over to this machine here. Okay, we can use the secure copy command to do that. And the syntax of that command, or the method by which we're going to do that, we're going to use SSH and copy. And to do that, we just do SCP. Okay, then we're going to say, what do we want to SCP? Let's SCP test2.pdf. Where do we want to SCP it to? 192.168.100.6. Okay, now we need to be a bit more specific because we're using SSH. Who are we going to log in as? We're going to log in as Michael. Okay, where do we want the file to go? We want it to go to /home/Michael. Okay, let's try running this, see what happens. Michael's password. Okay. Ignore this bash warning. It says here that it's 100% copied it. So if I head over to the other computer here and I type ls, that file should be here. There it is, look, test2.pdf, copied over. Okay, so that's just a quick demo of how to use SCP. All right, now we can also use SCP in the other direction. We could specify the IP address port file. We could specify the IP address and path of the file at the other side, and we could kind of pull the file towards us to do that. Now, I'm not actually sure what's in this test2.pdf. Let me just have a look and see what it is and make sure it's nothing that's going to like... Ah, it's got absolutely nothing in it. It's just a blank PDF. How exciting. Okay, so that was just a quick demo of some SCP between two machines and SSH. Let me just stop this now and see if anyone wants to ask any questions. Okay, so what I've done here is we've got some questions, and these questions are just based on what we talked about, or what I talked about there in the first part of the class. So what I would like each person to do, okay, I've allocated, now I'm just going to, some people are going to get 2 questions because some of these are quite easy. Like, for example, Jack, you've got a very easy question, so you can have another question there. And who else has got an easy question? Josh with a UA after it. Joshua has got a very easy question, so you can have that question as well. Okay, now, annoyingly, that won't send or justify, so let's just quickly fix that. We don't like that. Let's go, there we go. Right, so what I'll do is I will share this this file, and if everybody could just log into Office 365. If you've never logged into Office 365 before, then it's your lucky day. Hopefully everyone's managed to get there so far. So what I'm going to do is I'll share this, okay? Anyone with the link can edit. So let's copy the link. Here's the link. Let's click copy. And then what I'll do is I'll put this link into the chat, okay? And then if you could click on the link and then type the answer to the question that is associated with your name into the green box here, okay, that would be great. So let me just paste in the link. Now, what we'll do is I'll stop talking now and I'll go away, and then we'll return at 10 past 11, okay? And we will talk about these questions and answers. So that gives us 15 minutes, okay, from now. So here's the link in the chat there. Hopefully this works for everybody. I'll stay here until I see the first person appearing up here at the top. Usually we can see people appearing round about this area. They appear little names, and then I'll go away and we'll come back at there we go. Everyone's appearing, right? I'll stop talking now and I'll come back at 11:15 and we'll talk about, let's say 11:15, okay? So back at 11:15. What are the advantages of using VLANs? Right. Ability to segment a network, yes. If an adversary gains access, they're contained to one area, yes. We'll say one more. What else is an advantage? Let me think some more advantages. So you can divide up a network.
You get better performance because there is no like traffic, too much traffic on one broadcasting.
Security in a network contained to one area. What about? I suppose we could divide this out. And we could say to network devices, something like that. Okay. How can they separate large broadcast domains? Yes, that makes absolute sense. Yep, 4 bytes is good. Vlan ID. What is the Vlan ID though? What actually is it? What does it do? How does the stateless firewall work?
I couldn't talk
okay.
anything, Michael, but it is based on the. It is look at traffic. Well.
Yeah. Okay. So a stateless firewall only permits, or it would help if I was actually typing. Oh, I'm typing in. Hang on. I was typing in green, and we're actually using green. Hold on. Right. Let's make the text. Okay. Let's just make this text black so we can actually see it. Come on. I think there's so many people in the spreadsheet that it doesn't like me. It's not letting me change the color of it. Hang on. Let me just click away. There. Right. Oh, there we go. Thank you, whoever did that. Right. Only permits or denies traffic. Okay. Based on a rule. So there's no state monitoring with a stateless firewall. It only permits or denies traffic. Okay. That's all it can do. Right. How does a stateful firewall work? It tracks the sessions and monitors. Yes, exactly right. How does a DMZ? It segregates servers across like cell servers. Yep, perfect. Which device? DNS mail. Yeah, the most likely device we're going to find in a DMZ is a web server. Okay, public-facing web server. Right. SSL encrypts the data before it's sent. I suppose that's fine. DigiCert. Yep, that's good. Okay, what's the advantage of using SSH? SSH creates a secure tunnel between source and destination. Okay, secure tunnel, a secure shell. Okay, a secure shell. Let's do, I think this one, that one. SFTP is more secure because it encrypts your data. Exactly right. Don't confuse SFTP and TFTP. And limit login attempts. Yeah, exactly. I think though the key is this: limit login attempts, and the other important one is set a login timeout. Okay, if you make users wait not 2 minutes, but 10 seconds or something on each login attempt, then that improves things. Oh, right, Jack's updated this one. The VLAN ID tells the VLAN what device can access. What actually is it though? Actually, is it right? The VLAN ID is a number. Okay, is a number that assigns the VLAN. Okay, and this number is between 1 and 4096. Okay, there are some reserved ones in there, but those are the different VLAN numbers. Okay, so those are the questions. I'll make those available on the Moodle page. Hang on, let me just do save as, download a copy. Download a copy. Hopefully everyone can open an Excel file using their Office 365. I don't have Windows or anything. I'm just using Office in the browser here. Okay, just logged in to Office in the browser. Just go to office.com, log in with your college email, and you can use everything. You don't even need to download Office or anything like that. Right. Okay, so that is that's the questions. Here is the lab for this week. Now, let me just move this across and I'll explain what we're going to do. So, this week's lab builds on the skills learned in Lab 1. Do not attempt this until you have completed Lab 1. So the people who didn't do Lab 1, you need to do Lab 1 today. Okay, you need to do Lab 1 and you need to get in touch with me if you're stuck via the chat. You can either message me directly or just use our group chat and I'll answer your questions. Once we've done that, we're going to follow the steps in Lab 1, but we're going to create a second firewall, okay? And we're going to imaginatively name the firewalls Firewall 2, or Firewall -02, and Firewall -01. And we're going to create on those firewalls 2 users. On Firewall 1, we're going to create a user called Alice and a user called Eve. We're going to create Eve on Firewall 2 as well, and we're going to create a user called Bob. Okay? Now, what we're going to do is we're going to SSH, right, as Alice from this firewall, okay, into this firewall. Okay, so that says Alice. We'll just shorten Alice to ALI. Okay, Ali there. Okay, and we're going to SSH as Bob, right, over this way. Okay, so user Bob, sorry, other way around. We're going to, I'm confusing myself. We're going to SSH as Bob this way, and we're going to SSH as Alice that way. Okay, so you'll be able to log in as Alice because Alice has a user account on this machine. You'll be able to log in as Bob over here. Okay, now once you have SSH working both ways, okay, we're then going to edit a file, and the file we're going to edit is /etc/sshd_config, and then all we're going to do is we're going to put deny users Eve into the end of this file. Once we've put deny users Eve, we restart SSH with this sshd restart command, and then we try and SSH into Firewall 2 and Firewall 1 as Eve, and we should see a message saying access denied, and if that's done, you have successfully completed Lab 2. Okay, so for those of you that need to do Lab 1, you need to do Lab 1 first, then you need to do Lab 2. Now, I'll just make this available just now on the Moodle. So let's do week 2 show. So what we have here today is, let me just grab the questions somewhere from, so here are our questions that we just did as a group, and I'll move them up to here. There. So there's the questions in PDF format. There's Lab 2 instructions. Now, this week, this is what we need to add to the ePortfolio. Okay, let me just do show. Right, we need to add a screenshot of the output of IP address show on Firewall 1 and Firewall 2. We need to do a screenshot of a ping going from one firewall to the other, a screenshot of Bob successfully connecting with SSH from Firewall 1 to Firewall 2, a screenshot showing Eve being denied, and evidence of a successful connection on port 2222. So you're going to have to figure out how to change the default SSH port and show this working. Now, one very, very quick revision from last week, or a couple of weeks ago now, just to jog your memory. Your VI won't look as full featured as this, because I've got some plugins and add-ons and things. But absolute basic run through, if we want to edit a file, let me just quickly make a file, okay, called my file, okay, VI my file, right? And inside my file, okay, I'm going to put some text that says hello. Right, so now if I cat my file, I can see that in there we have some text called hello. Now, if we want to edit that file with VI, we just type VI space my tab to my file, and then we get into VI, pressing return. Okay, now, at the moment, we're in a mode called normal mode that we can get to by pressing escape. So we can't just come in here and start typing. We can move around, but we can't start typing straight away. To get into what's called insert mode, okay, you wouldn't get any prizes for guessing that you have to press the insert key on your keyboard, or you can press the letter I, okay? So we press I, you'll notice that my plugins down here tell me that we're in insert mode. So with I, we can now just type, I am typing a message, okay? Then when we want to save the file, we need to get out of this mode, okay? So we need to go back to normal mode to save. So let's press escape on the keyboard. And now we are in normal mode. And there are a few different ways to save. One of them would be to do Shift ZZ will save. Another way would be to do Shift : right quit. Okay, so there's just a really quick tutorial. So if we want to edit a file to deny or allow users, we'll do that using VI on the file. Okay, so those are the tasks for this week. That's Lab 2. For those of you that need to do Lab 1, you need to add Lab 1 to the ePortfolio and Lab 2. For those of you that just need to do Lab 2, just add the evidence for Lab 2 to the ePortfolio. And I will now stop talking and see if anyone wants to ask any questions.